All right, let's get ready to dive into something pretty electrifying today. We're going to be talking about ESD testing, specifically using the SESD 230 ESD simulator.
Oh, very cool.
Yeah, you sent us some info on this thing, and it's seriously cool.
Yeah.
We're going to kind of unpack what it does and how it simulates these like tiny lightning bolts, and why that's so important for making our electronics tougher, more durable.
Yeah, it's really fascinating how much engineering goes into something that most people just experience as a simple static shock, you know.
Totally. I get that it's about zapping electronics, but I'm curious, like, what makes this SESD 230 special compared to, say, me rubbing a balloon on my head and touching something?
Right. Well, I mean, first off, control. The
Yeah.
SESD 230 isn't just random static. It simulates very specific ESD events, according to the IEC slash EN 601042 standard.
Oh, wow.
Yeah. So this way, everyone's testing their gadgets against the same, tiny lightning bolt, if you will.
So it's like a universal measurement for how much zap a gadget can handle before, like, totally freaking out.
Exactly, exactly. And the SESD 230 can generate a whopping 30,000 volts.
Wow.
That's
Why?
way more powerful
30,000.
than a doorknob shock.
Yeah.
And it's designed to really stress test, devices to extremes, ensuring that they're robust.
Okay, so 30,000 volts, that's intense.
Yeah.
How does it actually deliver that zap? Like, does it shoot like little lightning bolts across the room?
Well, no, it's more controlled than that.
Oh,
It
okay.
uses two main methods.
Okay.
Air discharge, where the charge jumps through the air like a miniature lightning strike,
Hmm.
and contact discharge,
Sure.
where it flows directly through a point of contact.
So depending on what you're testing, you choose which method, like best mimics a real world shock. Like if I'm worried about someone touching my phone screen.
You would use contact discharge
Right.
to
Okay.
simulate that finger zap. But if you're testing a whole circuit board's kind of general vulnerability to it, air discharge might be more appropriate.
Interesting. It's like choosing the right weapon for a tiny little electrical duel.
Right, exactly.
But how do you know the zap actually hit its target? Especially with the air discharge, it seems like it could miss
Really?
pretty easily.
Well, that's where the quote, no contact indication comes in.
Okay.
So imagine testing a device with a painted surface, right? The charge might not be able to flow properly through the paint.
Right. Okay.
So this indicator tells you if that's happening, ensuring that you have accurate results.
Oh, so it's like a safety net to avoid like false positives, right?
Exactly.
So you don't think your gadget's tough when actually it just got lucky and didn't get fully zapped?
Exactly.
That's clever.
Yeah.
Okay, so let's talk about this 30,000 volt limit for a second. Is that the most it can do, or is that just kind of a starting point?
Well, it's the maximum for the standard test levels, but the SESD 230 actually lets you adjust the voltage in 100-volt increments, all the way down to 0.5 kilovolts.
Wow.
Yeah, so you have this fine-grained control to dial in the right zap for your testing needs.
Okay, so you can simulate like a whole range of ESD events, from like a gentle little static nudge to a full-on electrical smackdown.
Exactly, yeah, a wide range.
But what determines which voltage level is the right one to use? Is there like some kind of ESD rulebook?
There is. The IEC 61042 standard that we mentioned earlier
Yeah.
defines specific test levels, and each one has its own voltage and purpose.
Okay.
They're like different intensities of static shocks.
Okay.
From like a level 1, tap on the shoulder, to a level 4, you've got to be kidding me, jolt.
Right. Okay. So a phone screen might only need level 2 testing, but like a piece of industrial equipment might need to be able to handle like level 4.
Exactly.
Got
Choosing the right test level is crucial for making sure the testing is relevant
Yeah. Yeah.
to the real-world risks.
Speaking of the real world, I'm curious about how this testing connects back to like our everyday electronics. Like, do my headphones get zapped with 30,000 volts before I can listen to my tunes?
Well, not quite, but they have been subjected to ESD testing
Okay.
to ensure they can handle, everyday static.
Okay.
I mean, think about it. You touch your phone screen, you plug in headphones, you interact with electronics constantly, and all of those actions have the potential for ESD events.
Right. So this testing's happening behind the scenes to make sure that our gadgets can handle those everyday zaps without us even like realizing it.
Yeah.
That's pretty reassuring.
It is. It is.
It's like an invisible force field protecting our tech from, these tiny lightning bolts.
Right.
Okay, cool. But what about the SCSD 230 itself? What makes it so good at delivering these controlled zaps? Are there any special features?
Absolutely.
Okay.
One that stands out is the contact control feature.
Yeah.
So this ensures consistent contact between the simulator and the device during testing.
Okay.
So it minimizes variability and leads to more um, reliable results.
So it's not just zapping haphazardly, there's precision involved.
Exactly,
Wow.
precisely. It's like having a steady hand guiding those tiny lightning bolts
Yeah,
to ensure consistent and accurate testing.
that makes sense.
And it's not just about accuracy; it's also about efficiency.
Okay.
So the SESD 230 has predefined standard test levels
Right.
and the ability to run automatic test runs.
Okay.
So, this saves a ton of time and effort in the lab.
That sounds like a dream for anyone who works in the lab.
Right.
No more manually zapping each device over and over again.
Exactly. Exactly. And it eliminates human error and ensures consistency.
Totally.
And speaking of user friendliness, the display
Oh yeah,
is incredibly clear
it is. It's super straightforward.
and easy to read,
Yeah.
even for those who aren't electronics experts.
Yeah, even I could probably figure it out.
Exactly. You can easily see the selected test level, voltage, and other important info at a glance.
Cool.
And to top it off, you can power it with either battery or mains power, making it versatile for different testing environments.
Oh, so you could take it out in the field for on-site testing or keep it plugged in at your workbench for lab work.
Exactly.
That's very cool. But let's go a bit deeper into how it actually works.
Sure.
I'm curious about something called discharge impedance.
Okay.
It sounds like a mouthful, but what does it actually mean?
Yeah, it's essentially the resistance and capacitance involved in the ESD event.
Okay.
Think of it as the pathway the electrical charge takes from the simulator to the device.
So it's not just about the voltage, but also how that voltage is delivered.
Exactly.
All right.
It affects the shape and duration of the ESD pulse, which influences how the device responds.
Okay.
Imagine the difference between like a sharp, sudden jolt, versus a more gradual surge of electricity.
Okay, yeah, I'm starting to see the nuance here. So the SESD 230 has like specific values for discharge capacitance and resistance to make those shocks as realistic as possible.
Precisely. The documentation mentions a discharge capacitance of 150 picofarads and a resistance of 330 ohms.
Wow.
And these values are carefully chosen to align with the IEC 61042 standard, ensuring the tests mimic real-world ESD events.
It's all about setting up a controlled but realistic tiny lightning bolt arena.
Exactly.
And the cool part is that the combination of the fixed discharge impedance with the different voltage levels, it creates like unique ESD pulses for each test level.
Right, exactly.
So like adjusting the power and the path of the zap to test different aspects of the gadgets like defenses.
Yeah, it is.
Pretty clever. Well, I think we've laid a great foundation here. We've covered what ESD testing is, why it matters, and how this SESD 230 simulator kind of fits into the picture.
Definitely.
We've touched on some key features and concepts, but there's much more to explore. In the next section, we'll delve deeper into those specific test levels, the different voltage values they use, and what those mean for real world scenarios.
Absolutely.
All right, let's do it.
Sounds good. So we talked about how the SESD 230 can like dish out a range of electrical punches,
Right.
but it's not just about zapping things indiscriminately.
Right. It's about simulating those real world ESD events
Right.
in a controlled way. And that's where those predefined test levels come in.
Exactly.
We kind of skimmed over them before,
Yeah.
but I'm ready to like unpack each level
Oh,
and
yeah.
see what makes them tick.
Yeah, absolutely.
So they're like, what? A standardized set of ESD challenges, each simulating a specific level of electrical stress.
Yeah, you could say that.
Okay.
Yeah, like a standardized set of ESD challenges.
So it's like an ESD obstacle course for gadgets,
I like.
with each level getting progressively tougher.
Yeah, that's a great analogy.
Okay, cool.
So let's start with level 1, the most basic level.
Okay.
It simulates a relatively low energy ESD event using 2 kilovolts for both air and contact discharge.
Okay, so level 1 is like the introductory zap, just a gentle nudge to make sure a device has like some basic level of ESD protection.
Exactly, and it's often used for initial screening
Okay.
or for devices that aren't expected to encounter harsh ESD environments.
Right, like you wouldn't test a rugged industrial machine the same way you test like a delicate phone screen.
Exactly,
Okay,
exactly.
yeah.
So moving on to level 2,
Okay.
it steps things up with a 4 kilovolt zap, again for both air and contact discharge.
Okay.
And this level is more for devices that might experience moderate levels of ESD stress in everyday use.
Okay, so level 2 is for things that like people interact with regularly, like smartphones or keyboards.
Exactly,
Okay.
exactly. Those devices are much more likely to encounter ESD events than something like, a server tucked away in a data center.
It's like the difference between being out in like a crowded city
Right.
versus relaxing in a quiet park.
Yeah.
More chances of bumping into something or someone with static cling.
Yeah, great analogy.
Okay, cool.
Now with level 3, things start to get a little more serious.
Okay.
We see a difference in voltage between air and contact discharge.
Okay.
8 kilovolts for air and 6 kilovolts for contact.
Wait, why is the voltage higher for air discharge at this level? Is air suddenly more resistant to tiny lightning bolts?
Well, think of it like this. In air discharge,
Okay.
the ESD arc has to jump through the air,
Yeah.
which requires more voltage to overcome the air's resistance.
Okay.
In contact discharge, the arc has a direct path, so it needs less voltage.
Oh, okay. It's like the difference between throwing a ball over a fence versus rolling it through an open gate.
Exactly,
Yeah.
exactly. And level 3 is often used for testing devices that are expected to handle, more demanding ESD environments,
Okay.
like industrial equipment or automotive electronics.
So gadgets that live in a rough and tumble world,
Right, exactly.
more ruggedized stuff.
Okay, now I'm ready for the big leagues.
Okay.
What does level 4, the highest standard test level, what does that throw at our electronics?
Yeah, level 4 is where we really crank things up.
Okay.
It uses a whopping 15 kilovolts for air discharge and 8 kilovolts for contact discharge.
Wow.
And this level is reserved for testing devices that absolutely need to withstand the most severe ESD events.
So this is for like mission critical equipment, aerospace electronics, stuff where like an ESD failure is not an option?
Precisely.
Mm.
We're talking about devices where, a tiny lightning bolt could have like catastrophic consequence.
Right, okay. That's intense.
Yeah.
But I thought the SESD 230 could go up to 30,000 volts. What about level X? Ah, yes, level X. That's where the SESD 230 really flexes its muscles.
Okay.
It allows you to go beyond the standard test levels
Okay.
up to that full 30 kilovolts
Wow.
for both air and contact discharge.
So level X is like the bonus round, the ultimate ESD challenge.
Exactly.
Now, why would you need to go that extreme?
Well, there's a couple of reasons.
Okay.
First, some manufacturers might have internal standards that exceed the IUC standard.
Right.
They want to push their devices to the absolute limit.
Like an ESD Ironman competition for
Right.
electronics.
Exactly. Yeah. And second, as technology advances and components get smaller and more sensitive,
Right.
we might need even higher test levels to really challenge those devices
Okay.
and ensure that they're robust.
So it's like the ESD arms race is heating up with ever smaller components demanding like ever stronger tests to survive.
Yeah, that's a great way to put it. All this talk of test levels and voltages is fascinating.
Yeah.
But what does it actually look like when you're testing a device?
Right.
Like, is there a tiny lightning bolt show?
Yeah.
Well, not quite a light show, but the documentation does provide, a visual representation of the ESD event for each test level.
Okay.
They show the waveform of the current as it flows from the simulator to the device.
So it's like a blueprint for each level's electrical punch.
Exactly. And these waveforms, they reveal key characteristics like the rise time, the peak current, and the decay time.
Okay, so break those down for me. What do each of those mean?
Sure.
Like what's rise time?
So rise time tells us how quickly the current reaches its peak value.
Okay.
Essentially how sharp or abrupt the shock is.
So a fast rise time means like a sudden jolt,
Right.
while a slower rise time means a more gradual surge.
Exactly.
Okay.
Then there's the peak current, which indicates the maximum amount of current flowing during the ESD event.
Okay.
And this is a measure of the energy involved.
Okay.
Higher peak currents can be more damaging to sensitive components.
So it's not just about how fast the zap is, but also like how much force is behind it?
Right,
Oh,
exactly.
okay.
And finally, the decay time tells us how long it takes for the current to drop back down to zero
Okay.
after the peak. So basically, how long the ESD event lasts.
So a short decay time means like a quick burst of energy,
Right.
while a long decay time means a more prolonged surge.
Exactly.
Oh, okay.
And by analyzing these waveforms, we can understand how different ESD events might impact a device.
Okay.
Higher test levels generally have faster rise times, higher peak currents, and shorter decay times,
Okay.
making them more intense and potentially damaging.
So it's not just about the raw voltage,
Right.
but the entire shape of the ESD pulse,
Right.
which is influenced by the voltage, the discharge impedance, and the chosen test level.
Exactly.
It's like analyzing the impact of like different types of punches in a boxing match.
Right.
Each punch has a unique combination of like speed, power, and duration,
Exactly.
resulting in different effects.
Yeah. That's a great analogy.
Okay, this is all starting to make sense.
Good.
Those waveforms are like a secret decoder ring for understanding the nuances of each ESD test level.
Yeah, I like that.
Okay, cool.
Yeah, and understanding these nuances is crucial
Mhm.
for making sure the testing is both rigorous and relevant to the actual ESD challenges
Right.
a device might face in the real world.
This deep dive into the test levels and waveforms have been really eye-opening. I'm starting to appreciate like the complexity of ESD testing
Yeah.
and how much thought goes into like replicating those real-world shocks.
Yeah, that was
But there's still a whole section in the documentation dedicated to like technical data for the SESD 230.
great.
What juicy details are hiding in there.
Yeah, that's where we get into the nitty-gritty of the simulator itself.
Okay.
We'll uncover some fascinating insights into the output voltage adjustment, polarity control, charging resistance,
Mhm.
and more.
Okay.
It's like peeking under the hood of a high performance ESD machine.
All right, let's fire up those technical specs and see what other gems we can uncover.
Let's do it.
We've explored the SESD 230 inside and out,
Yeah, we really have.
but we left our listener with a pretty big question.
Yeah.
What's next for ESD protection?
Yeah, it's a question that has a lot of us in the field pondering.
Yeah.
As electronics get smaller
Right.
and more complex, those tiny lightning bolts become an even bigger threat.
Right. It's like trying to protect a microscopic city from a thunderstorm.
Exactly. Yeah.
What are some of the ways that researchers are tackling this challenge?
Well, one really interesting area is the development of new materials with built-in ESD protection.
Okay.
So imagine a material that naturally conducts those static charges away from sensitive components
Yeah.
without needing, bulky shielding or anything like that.
So instead of adding on protection, the material itself is the protection?
Exactly.
That's elegant.
Yeah, it's a very elegant solution,
Wow.
and it would revolutionize how we design electronics, allowing for even smaller and more powerful devices without sacrificing ESD resilience.
Yeah.
But it's not just about the materials themselves; it's also how we use them.
Okay.
Researchers are exploring new circuit designs
Okay.
that minimize ESD susceptibility.
Okay, so like building a house to withstand earthquakes, but for electronics?
Yeah, that's a great way to think about it.
Okay.
These designs might incorporate redundant circuits,
Right.
or clever layouts that divert ESD currents away from critical components,
Okay.
essentially creating safe paths for those tiny lightning bolts to follow.
So it's like ESD traffic control, guiding those electrical charges away from the sensitive areas.
Precisely. Yeah, I like that analogy.
But beyond like prevention, there's also the idea of real-time ESD protection,
Right.
like active systems that detect and respond to ESD events as they happen.
Right. Yeah.
That's like having a tiny ESD security system always on guard for those sneaky static charges.
Exactly. Yeah.
Okay.
Think about tiny sensors embedded in devices
Right.
that detect ESD events and trigger protective measures,
Right.
like shutting down power to vulnerable circuits,
Yeah.
or redirecting the current.
Wow.
This kind of real-time response could be a real game changer as electronics become even more integrated into our lives.
It makes sense, especially with things like wearable tech, smart homes, even self-driving cars. ESD protection isn't just about keeping gadgets from breaking.
Right.
It's about like safety and reliability in a world that's increasingly reliant on electronics.
Absolutely. As
Yeah.
electronics become more pervasive,
Right.
the stakes for ESD protection get higher.
That's a good point.
Yeah.
It's fascinating to think about like the ingenuity and innovation that's going into this field.
Yeah.
We've come a long way from like basic shielding techniques, and it seems like the future of ESD protection is all about like staying ahead of the curve as electronics evolve.
I totally agree.
Yeah.
It's a constant back and forth between the relentless miniaturization of electronics
Right.
and the ever-evolving strategies to protect them.
Well, we've covered a lot of ground today,
We have.
from the fundamentals of ESD testing
Yeah.
to the future challenges and opportunities in the field.
Yeah, it's been a good deep dive.
I hope our listener feels empowered to think differently about those seemingly harmless static shocks.
Yeah, me too. It's easy to take for granted the technology that works seamlessly in our lives, but
Right.
but there's a whole world of engineering and innovation
Yeah.
dedicated to ensuring that reliability, and ESD protection is a crucial part of that story.
It really is. Well, thanks for joining us on this electrifying deep dive into the world of ESD testing with the SESD 230.
It's been a pleasure.
We hope you've gained some new insights and a newfound appreciation for the unseen forces at play in our electronic world.
Absolutely.
All right, thanks for joining us. Until next time, stay curious and stay grounded.
Take care.